In this session, we'll see about multiplexing. The concept multiplexing and spreading is under bandwidth utilization. Bandwidth utilization is the use of available bandwidth to achieve specific goals. Efficiency can be achieved by multiplexing. Privacy and anti-jamming can be achieved by using spreading. Multiplexing is used to combine multiple signals for transmission over a single line or a single media. Multiplexing is done using a device called multiplexer. It is shortly known as MUX, that combines n input lines to generate one output line, that is many to one, which means many input into one output. At the multiplexer has several input and one output. At the receiving end, a device called demultiplexer, it is shortly known as DMAX, is used to separate signals. Demultiplexer has one input and several output. This is the example diagram for multiplexer. Multiplexer takes 4 input line and diverges them into a single output. The signal from 4 different devices is combined and carried by this single line, which means single communication channel. At the receiving side, a demultiplexer takes this signal from a single line and breaks it into a original signals and passes them into a 4 different receiver. This is the image for no multiplexing. Here no multiplexing used. This is the example for multiplexing. There are 3 basic multiplexing techniques. One is frequency division multiplexing. Number 2, wavelength division multiplexing. Number 3, time division multiplexing. In frequency division multiplexing, it is an analog technique. Medium is divided into n channels. A multiplexing technique that use different frequencies to combine data and separate data. Here device 1, device 2 and device 3 is divided in the basis of frequency. Device 1 has a frequency channel of range from 1 to 5. Device 2 has a frequency channel of range from 7 to 12. Device 3 has the frequency channel of range from 14 to 19. Next, wavelength division multiplexing. It used in the analog signal, a type of multiplexing developed for use in optical fiber. Light has a different wavelength, which means a color. In optical fiber mode, multiple optical carrier signals are multiplexed into an optical fiber by using a different wavelength. Here the difference between the frequency and the wavelength is only frequencies are very high in wavelength division multiplexing than frequency division multiplexing. But in frequency division multiplexing there is a lot of frequency, but here the optical signals are used. Optical signals are transmitted through fiber optic cable. The difference between frequency and wavelength division multiplexing is the frequencies are very high in wavelength division multiplexing. Next, time division multiplexing. Frequency and wavelength division multiplexings are analog technique. Time division multiplexing is a digital technique. The type of multiplexing that combines data by assigning each stream a different time, which means all signals operate at the same time with different frequency in frequency division multiplexing, but in time division multiplexing all signals operate at a different frequency with different time. There are 2 types of time division multiplexing. One is synchronous and another is asynchronous. In synchronous, the time slots are not fixed. In asynchronous, the time slots are not fixed, which means it dynamically allocated the time slots to the device. In synchronous time division multiplexing, a multiplexer always assigns the same time slot to each device. In synchronous, the time slots are fixed. In asynchronous, the time slots are not fixed. Thank you.